Hi, thank you, Passive House Network Empire State, for this invitation. Today, we will share progress on the Catskill project, a heading to zero carbon housing development about 100 miles northwest of New York City. According to our friends at AI, approximately 1.4 to 1.5 million new privately owned housing units are authorized or started annually in the US as of late 2024, early 2025. Single-family construction remains the largest segment with nearly 1 million starts in 2024. We all want to get Passive House to scale. We cannot ignore the single-family house. Greg Hale, who I saw on the screen there a moment ago, is a founding principal of the Catskill Project. He and our team gave a presentation at a national home builders conference a couple of years ago. After the presentation, a fellow from a large national single-family home developer builder came up and said, paraphrasing here, "It's great to hear about your work on this project. You are our R&D department." This is worth repeating. You are our R&D department. After you work through these issues, we can bring it into our projects. The Catskill Project's mission is simple: develop a working prototype for decarbonized single-family housing in rural environments. Passive House is fundamental in addressing this goal. Regenerative design is also critical, designing in collaboration with the myriad of Earth's ecological systems, air, water, soil, geology, wildlife, forests, and vegetation. The Catskill Project seeks to do this in equal parts as well. This aspirational development is 160 acres, comprised of 3 phases with 25 planned house sites. So far, we have built 6 houses within the first phase. The first phase includes a 40-acre conservation easement with a dynamic topography, several waterfalls, accessed by a light touch 1.5-mile hiking trail, which is maintained as a community asset. Here is the Phase 1 site plan encompassing 90 acres and 11 planned houses. Local zoning mandates a 3-acre minimum lot size. This zoning, coupled with topography in large part, has created this appearance of cluster housing. In the lower left-hand plan, you can see Phase 1 is outlined in red, Phase 2 in blue, and Phase 3 in green. Guiding principles for development of the land include retention of trees wherever possible and salvaging those trees, which need to be culled, for reuse wherever possible. The HOA establishes environmental mandates as well. No fossil fuels for heating, hot water, cooking, clothes drying, or recreation vehicles. All electric power, either solar or community solar subscription, and strict limits on tree clearing. Early in project concept development, panelized construction was identified as a strong execution fit from a replicability and quality control standpoint. We are proud to have partnered with Bensonwood for these first 6 builds. The parameters of their system had a meaningful influence on our design process. We studied their plans and typical wall and roof sections to understand the kit of parts which would drive our designs. We developed new plans, sections, and elevations that worked within those parameters while reflecting our project design goals. Over the course of the project, we have designed 4 total models, all under 2,300 square feet. The design prompt from the client was modern rustic. The balsam, the watercolor on the lower right, became our first build. We turned more toward a contemporary take on the vernacular farmhouse for our newest model, the Red Hill, second from the upper left. This is the balsam. As noted, this was our first build, originally constructed as a model home. This has been certified by PHI as a Passive House low-energy building. The balsam is 2,300 gross square feet, south-oriented, utilizes integrated passive shading by way of a feature corner, plus fixed shading over south windows. as a Zender 350 ERV system. It was designed initially with a 1.5-ton single-zone Fujitsu air source heat pump. During construction, our duct pressurization test for this system was fine. However, at completion, after the chipboard install, our balancing test showed significant drop at CFM at several rooms below the design calcs, what we think might have been related to unexpected friction loss in the ducts. We subsequently added the 1.5-ton supplemental unit. We have completed 2 additional balsam builds to date for buyers. A couple changes from the model home. We went to a 2-ton single-zone HVAC system. This allowed for a buffer in case there were greater friction losses than anticipated, and in addition, simply provided some greater capacity. We moved the machine into a more serviceable location and put in a manual damper, allowing one to direct greater airflow to the upper or lower floor based on the season. We added humidification to each house as well. We had experienced very low humidity, around 11% in the model home, unoccupied, that led to a severe gapping in our wood flooring. An homage to the vernacular farmhouse, our newest model, the Red Hill, was developed in response to rising construction costs and our desire to have a less expensive offering. It seeks to integrate as many learnings from our balsam builds as possible. Sitting at under 1,800 square feet, it is a compact square plan, efficient in its material use, while maintaining a marketable 3-bedroom, 2.5 bath layout similar to the balsam, with the primary suite on the first floor. The house is designed to receive solar panels on the south-facing roof. There's an attached carport, and it has the same option as at the balsam to add a 3-season room with an upper deck. Heating and cooling is provided by 2 1-ton heat pump systems, one at each level with separate thermostats. This design uses ICF frost walls in lieu of slab-on-grade warm form foundation at the balsams. The Red Hill was modeled in both PHI and PHES standards, and a decision was made to pursue certification through the PHES prescriptive path. We're at the latter stages of construction for the Red Hill that we are certifying through that pathway. We have received positive market response to this new model, with 2 sold and 1 more currently listed. Lot 2 with the pond, the upper 2 photos, has an accessory ceramics woodworking studio. And I'll pass it on to Remy here.
In terms of our passive house strategy, tailoring Benson Wood's envelope offerings for a passive house application was easy, provided that the robust wall and roof assemblies you see here live within what is already their standard kit of parts. So for this climate zone 6A, you're looking at a 2x10 exterior wall infilled with dense pack, an OSB air barrier, and an insulated interior service cavity as well. At the roof, 16-inch TJIs infilled with dense pack help us achieve an R80. The balsam builds to date have utilized the insulated slab-on-grade foundation that you see in this detail here. For our Red Hill builds, as Buck mentioned, we are testing an ICF frost wall alternative. For the Red Hills, we also moved, or really Bensonwood moved to a 9.5-inch I-joist exterior wall framing member instead of the solid 2x10s. And interestingly, to hit prescriptive R-value requirements for PHES, we actually had to bump up what was a 2x3 service cavity at the balsam to a 2x4 service cavity at the Red Hills. Let's see. For PHI certification at the balsam, the only real modification that had to be made to Benson Wood's upper envelope offering related to thermal bridging. So the thermal bridge modeling required for the balsam ended up being quite extensive. There were 8 unique window and door typologies, which translated to 16 unique head jamb and sill threshold details, which had to be modeled. A few of these conditions are shown here. We have not been required to model thermal bridges under the PHES prescriptive framework we're pursuing for the Red Hill builds, though we are, of course, required to maintain continuity of insulation in our detailing. Here is one delightfully unsophisticated solution used for providing a thermal break at typical windowsills at the balsam. Here, drainage channels were site cored into rock wool over insulation, shown in yellow here, to provide a thermal break at the windowsills without compromising water drainage. The construction of these houses comes together in a pinch on site. It's really quite remarkable. The wall and roof panels manufactured at Benson Wood's factory in Keene, New Hampshire, come over on a flatbed truck, and then they're assembled in a matter of days. Benson Wood, importantly, delivers a passive house level blower door test result as part of their contract with us before they leave the site. Rough-in MEP and the subsequent interior and exterior finishing of these houses is then executed by direct subcontractors to the Catskill project. Whenever possible so far, we have made it a mission to track the performance data of these completed passive houses. This case study that you're looking at here took place at our first balsam build. Our mechanical engineer, Kramer Silkworth at Bowcraft, set up a series of temperature and humidity sensors, and we then proceeded to turn off the heat for 7 days in the dead of winter. I'd like to say that we weren't surprised by the results, given that we've been spreading high performance and passive house gospel for over a decade now, but with a validation like this one, we were. Over 7 days with 3 nights of sub-zero temperatures as low as -12, the interior temperature of the balsam never once fell below 50 degrees overnight, and each day, even in overcast conditions, it in fact climbed back up to 60 degrees. This served as a remarkable proof of concept from a resiliency standpoint in a region prone to weather-related power outages. We've also collected feedback from some of our existing homeowners to better understand the real-time performance of the houses that are now occupied. One homeowner has been tracking their energy use and solar generation. Since move-in in 2024, they have consistently seen more power generated than they have consumed. Another homeowner pays only the cost to carry their NYSEG or electric account for 9 months out of the year. And our third homeowner, who Buck mentioned happens to be a partner in the development and is also sitting in on this meeting, so we can pick his brain after. He installed his panels more recently, back in April of 2025, so he doesn't have a full year of data yet, but he suspects that he's tracking towards less annual production than it looks like his neighbors are, likely due to tree coverage on the site. We've made strides to think beyond the bounds of operational energy alone at this project and begin to think, specify, and source critically to minimize the embodied carbon of our construction as well. One commitment that the project has made to this end has been to salvage, mill, and reuse deadfall, at-risk species, and trees fallen for house siting. You see here in this video trees from our site sent to mill at Labrador Lumber on the southern tier of New York. Ash, maple, and cherry are dried and milled so they can ultimately see a new life as finished flooring, trim, and wood ceiling panels in the houses. There is something special about being in a space that is, by way of form or material, in direct dialogue with its surrounding environment. Here's a list of some additional material selections we've made with these circular economies and low global warming potential in mind. We utilize locally sourced native hemlock siding to clad these houses, reusable slate tiles at the building skirts, which are designed to be dismantled and reused at end of life. We are also very careful in our use of concrete, pursuing slab on grade construction wherever possible. We specify dense packed cellulose instead of foam insulation. In terms of interior finishing, we've had great success with Rich Light countertops, which is a recycled wood pulp material that's FSC and Green Guard certified. And we've been pretty loyal to Fire Clay Tile. They're certified climate neutral, manufactured domestically, 90% waste diversion. And I believe their factories are powered by 100% renewables as well. So for future builds, there's lots to consider. We'd certainly like to further close the gap between our tracked embodied carbon so far. We've used the EC3 tool for kind of preliminary estimating there and what's ultimately achievable for the project. Addressing operational carbon through high performance building design, as we all know, is thankfully becoming increasingly an industry norm and considered a basic requirement for good architecture. The mindful reduction of embodied carbon in materials and construction processes is certainly next in line for the throne of critical importance.
We've also included here some considerations for our future builds as our design offering continues to evolve. We are currently, based on the most recent weather we've been experiencing in the Northeast, investigating the addition of a supplemental electric resistant heat system to the air source heat pump for times of extreme cold where the system just can't hold temperature at the set of the thermostat. We are thinking through the potential use of a thermal battery, which we learned about through Passive House Network webinar recently. We're studying the impact that snow buildup has on the efficiency of PV panels through the winter. We have our roof is a 2.5 and 12 roof pitch, and our solar panels for the balsam are on the garages, which are intentionally, they're facing the south. So the balsam the shed faces to the north, so we don't have those on the building. But we designed the garage as that solar panel location. 2.5 and 12 works for it's efficient enough to get solar, but it definitely holds more snow than the Red Hill will on its system, which is an 8 and 12 pitch. So we're looking at that situation. We are continuously improving our HVAC designs and approach based on real world system operation and data collected from our homeowners. This we find when, as we talk with Kramer Silkwork, who's been an amazing consultant colleague along this whole process with us, that the equipment is evolving, the science is evolving. It's very important for us as a community to get this information back to the engineers in terms of how these buildings really work. They're a model initially, they're a prediction. So how does it really do? And we are finding that our houses are working well, but we are definitely dealing with questions about, this question about extreme cold that I just mentioned. It turns out I learned talking to Kramer that, New York State code requires, I think, 75 for cooling. 75. You don't have to get it below that. And I may be wrong. Someone may know more about that, but we had a potential buyer wanted 71 all the time. Like that's a lift. Like that's a different system. And so it's very, very important when you're in the market of selling these projects. It's just not for a single owner necessarily. Anyway, we're preparing also for the buyer who will want a gray water system. We'd like to move to a mandate on low global warming potential concrete and refrigerants. And finally, as well as panelized construction has served us, we are considering testing a stick build as a possible cost-saving tool for future builds. And that is our presentation, and we'd love to have a further conversation with all of you.
That is amazing. And I am looking to see, I thought I'd seen one question here. Um, there's a comment about the sill flashing detail and how fantastic that was. Ben, do
Sure.
you want to speak to that?
Yeah, you said this was aluminum sill. I mean, that's a difficult thing to really get right, and it looks like you've done that pretty well here. Most people have gone to using the fluid applied membrane flashings to eliminate that thermal break.
Mhm.
And it's nice to see that the metal's not completely gone, and we can still do it in a passive manner. So.
Yeah, we called it delightfully unsophisticated for a reason. Um, it was working with the contractor on site to kind of work through how this might actually get done, and it works perfectly well. I don't think there's need to engineer it much further.
No, we found where the weep holes were.
Yeah.
The weep holes are come out, the window has designed weep holes. So at that point, we knew we had to have an opening, underneath where the insulation was.
Mhm.
So that's where that channel, we cut was at the weep hole locations.
Yeah.
There's a question in the chat. Can you share any ballpark construction costs for Red Hill model with or without site prep?
I I would, Greg is Greg is raising his hand. We are, I'll just say simply, we are the costing, trying to nail down costs is so hard on these projects. And we just built literally two of the Red Hills. They all got built at the same time.
Mhm.
We had three Benson Wood Red Hills erected between December and January of December 24 and January 25. They delivered and erected the three Red Hills. So they've been going on, and we've been working on it for months beforehand, but it was a great example of the benefit of panelized because it was very cold, but they could erect these houses and they're insulated with the windows in place, and the contractor could work the next day, with a little heater in it and be good to go. So in any case, I'm saying this because we had three of them going at the same time. We built the last third one is just about finished. So we probably have a lot of pricing data on the Red Hill, which I'll pass it on to Greg if you'd like to say anything uh, regarding that cost question.
Thanks, Buck, and hi, everybody. Yeah, so it's a little hard to pinpoint because things are different on the different houses. If you're doing cost per square foot, the way I think about it is, and it's great that we have this picture up here, but I try to isolate the cost of the carport and the cost of the elevated deck and the three-season room below and take those costs out of consideration to get a price per square foot of the basic house, which is, 1,783 square feet or something like that. Anyway, with those things in mind, we came out, I'd say between 450 and $500 per square foot. A lot of that is finish costs. We don't go to the super premium finishes, but everything's really nice. It's custom millwork and stuff like that. And we're trying to figure out ways to bring that cost lower. We want to make these houses more accessible to more people. So we're thinking about a bunch of different things. But I'd say, yeah, 450 to 500 per house, and that's after you have done the site work. Our site work is fairly expensive here. We've got a lot of topography, so a lot of grading and everything's on its own septic and its own well. So our site costs have run north of $100,000 for each property, including the grading and the driveway. We build a really high quality driveway for people. Anyway, that's what I can let you know.
Awesome. Are you able to elaborate on the interaction with Unity? They proposed assemblies and a 2x2 grid, and you customized within that format. Were there constraints that limited you?
I'm happy to elaborate on that. Yeah. So we decided we were going to partner actually specifically with Benson Woods super early in the process. So our design process definitely benefited from an early understanding of what their constraints were. If you're doing a fully custom design with them, I think that their constraints are very limited. I don't think there's much. They do operate on a 2x2 window grid. They specifically advised us. We went to them and said that we wanted to build these as affordably as possible, and we wanted to stay as far away from a custom build price with them as we could. And so they did direct us to their Unity Home kit of parts package. They have a lot of different design offerings there, and essentially said, hey, have a look at these, pick a few and see if there are adjustments that you can make to customize a Unity, while working within what was important that be maintained, which was that 2x2 grid as it applied to building footprint door openings, and wherever possible to utilize, they have standard bathroom sizes and layouts. I'm not sure how close to those we ultimately stayed, but maybe close. So it did drive, our early SD looked like reviewing every single house plan that Benson Wood had ever drawn, and creating different volumetric models, and what we came out with, the balsam, looks completely different than anything that they do offer, but the actual footprint, the cadence of windows, some key bathroom locations and relationships were in fact maintained, which allowed us to keep us more on the costing side of a standard product offering than their custom product offering. An important piece if you're considering working with Benson Wood, it's a really good application if you intend to repeat builds. They have soft costs, which would seem obvious, built into their costs because they virtually fabricate essentially the design. So there's a whole engineering process that occurs, and then a virtual fabrication process that needs to happen on their end. So there's a sunk soft cost for getting a design fully baked and into their system, and then you kind of amortizate that cost out over the course of however many builds you replicate.
And it's important to a couple comments. One, we did dozens of these, whatever's on the screen here. We did many, many more, and we edited it down, and we gave a presentation up in New Hampshire. And Ted Benson, at the end of the presentation, he said that we had done a good job of coloring within the lines of their system, whatever that meant. I mean, we were trying to push it, but we wanted to still be within the line. So if any of you with young children, you can imagine the kind of drawing I'm thinking about. But the other important thing he told us, which is important in the world of this scaling single family, like panelization is critical, or volumetric modular, to do houses at scale at a good cost. The thing he kept telling us was, you're selling a product, and architects, speaking on the architects, for the architects in the room, we're designed to basically talk to clients and give them whatever. We have a career of trying to give them what they want, like, oh, we can do that, or we can do this, we can make that change, this and that. And he said, this house is a product. Like, you can't make much of a change before you you're out. It's not a product anymore. Like you don't go to Apple and ask to change the color of your phone, So it's a mindset, that one gets into. But we've Bensonwood's been wonderful to work with.
Have you considered doing slabless construction to save on concrete? And what type of detail for the wall are you thinking for the stick built?
Uh, I I would love it if we were talking about slabless. I would love it, but we're very far away from that. We went with a concrete slab as for the model, and it was very successful from a marketing standpoint, and it's less expensive than if you put in a frost wall and frame a floor for a house. You've got the framing and the wood flooring costs on top of that stem wall. It's to pour a slab, a thickened haunch slab, is we felt when we were working with our contractor on the model, he confirmed for us that's the least expensive thing we could do. So we've done it, and our buyers love the concrete slab. In a passive house that's insulated well, they're not cold, and there's no radiant floor in it either. So it's comfortable. So I wish, yeah, well, we could bring it into our thinking about our next houses. It
Yeah.
would take it. I don't know if it'd take down costs necessarily. Probably would, but it certainly would remove the concrete and embodied energy that we're fighting with the slab.
And then the second part of your question was what type of wall assembly we'd be pursuing for a stick build option. And we're still in the process of making that determination. So if there's anyone, if any of the attendees feel like they've cracked the code on the most cost-effective way to stick build passive house, we'd certainly be interested in hearing it. Our first instinct is a staggered double stud assembly. But yeah, I'll throw that question back out to the group in case it sticks.
Yeah, because we have a challenge because we in considering it, we have to deliver the exact same house that we have. I mean, the Balsam or the Red Hill, but it's got to meet the same passive house characteristics. So we actually have to reverse model something to that specific plan
Mhm.
and form and window layout. So yeah, anyway, it's a good question from Remy there.
Well, that's a good segue. Like, what did Bensonwood learn from you and think about doing a passive house base model in the future?
They we've started this like 6, 7 years ago now. We've been talking to Bensonwood for a long time. I don't know I haven't looked at their offerings, but they had a very good before we arrived, they had a very good wall. Like
Yeah.
it was technically, and they have it's called techniques or
Technics.
They have
Tectonics.
Yeah,
yeah,
tectonics.
tectonics. They're into this, and we just took their highest level system, and we just had to add cavity insulation to get it to passive house level for our climate zone. So they were close. The weakness or Achilles heel was the thermal bridges. I mean, I remember at the first factory visit, I walked up, I was looking at the windows in the wall. I was like, yikes, that's a problem.
But I will
But-
say I'd be curious. I mean, we've also now gone through 6 of these builds with them, and they've been kind of staggered, but there were definitely like as related to the thermal bridging. When we segued from our balsam builds to then contracting for these Red Hill builds, they had made improvements. Like they're on their standard window details and things of that nature. So I would be curious for anyone that would solicit a price from Bensonwood or go forward with the design, how much some of those details have improved as a matter of course. They want to be building the best buildings possible. So, they're always looking for ways to improve.
If I could pipe in here just a sec, uh, I I think Buck and Remy are underselling the influence that we've had, or maybe I'm just overthinking about it. But I think we've pushed them. Um, I don't believe they built a passive house before we came in. And I believe they have built other passive houses since that beyond ours. We certainly can't take all of the credit, but I think we've been an influence. They did come out with a modified vented roof panel after we brought up issues of how we had to modify their initial offering in the field. And then the other thing I'd say is, I don't know if there's a one-to-one connection, but since we started with our carbon neutral community, all electric, Bensonwood will not build fossil fuel buildings anymore. So sometime in there, they got the message and they're only working on all electric. So, I think it's been a great partnership. I'm probably thinking we had more influence than we did, but what's the harm in that?
Yeah. And we're all on here so we can ping them and let them know how great it is that they're doing that. Did you have any thermal bridge problems with the roof system?
With the roof,
Let's go to our thermal bridge.
I think
Slide.
with the roof, I'm going to think every issue was window or door sill related, window jam related. But I don't remember the roof no, I don't think
Not that stands out to us, though we could trace back through that for the balsam.
Yeah, I don't remember that being there were some that just hung around, like they were tough to work, and we got excellent help from Ed May along the way from Building Type. Many of you may know him. He was our thermal. We know enough thermal bridge modeling to get into trouble, and we call Ed.
I think John Mitchell's on here.
Oh, is John Mitchell on?
Well,
John.
maybe it's John that's actually doing the model,
Might have been
building.
John. I don't know.
Thank you, John.
Maybe Ed was the front man.
There's a lot of questions about the insulation under the slab.
Okay. The rigid. We're talking foam.
It's foam.
That's foam. We don't love it either. Are there specific questions? Are we right in our instinct that it's that folks aren't loving the fact that there's EPS there? Or is there another question related to it?
Feel free to just unmute.
Have to put in.
Say that one more time.
How many inches of EPS did you have to put in? And did you place geofoam underneath the footer of your monolithic slab?
So what you're looking at here is a product called Warm Form. That's what's forming the thickened haunch at the slab. And if I recall, this is a 6 inches at the slab edge. And then each of these pieces of rigid, and these would have been EPS, are 2 inches.
I think they're 4.
They're 4 inches each. Okay. Yeah, so we have a fair amount of foam buildup here, but your second question was about a geofoam underneath here. Would that be at the wing insulation? Yeah.
The ASTM spec for the geofoam is something that it has less compressibility than regular EPS. So I have a feeling the Warm Form, at least for the part that the concrete is setting on, is geofoam.
Right.
That is, I would have, it's type 9 it's got a much higher PSI capacity on the perimeter and under any, we have an interior bearing wall in the balsam that we've got a continuous, again, it changes from type 9 to type 2 or something, or under the slab. So that's correct.
And someone had brought up foam glass that I see Greg is using now, but do you want to discuss that a little bit?
Oh yeah, no, we love that idea. We haven't
Used it.
we've used it. Yes, we didn't at the time the first balsam was built. I don't know if the foam glass was available. It probably was. I mean, but anyway, we didn't use it. We have used it though with the Red Hill, and this was, we went for various reasons to, our contractor wanted to try a stem wall application with ICF. But with the Red Hill, we needed to put continuous insulation under the whole foundation, even with the stem walls. And we found out that the only way we could do that was we used aero aggregate, which is out of Pennsylvania, not gravel, but it's the same material, similar. And so aero aggregate, we went continuously under the whole foundation and connected that effectively with the ICF system so that we could get continuity under the whole foundation. And we had to take a step. There was a lot of resistance, number one, from our excavator and code enforcement officer. They were absolutely didn't want to do it. They said, no, you don't do that. You put it on soil. It's on soil. It's on soil. I think, well, turns out that the aero aggregate has a higher bearing capacity than our soil does. We're not building in great soil, bearing capacity. But I talked to our civil engineer and about what we'd have from a soil bearing capacity. And I realized that the aero aggregate's like 25% higher than the soil is that we're bearing on anyway. So we did get it approved. We got an engineer helped us from aero aggregate, and we got documentation, had to run it through the code guy. And as long as I stamped it, we were good. So
And
it's under there now.
there's a comment here that gravel is manufactured with renewable energy.
Oh, fair. That's it. I didn't realize that. So in other words, the aero aggregate factory is maybe using something that's non-renewable in its
Or
process.
maybe they need to be pushed a little to keep
Yeah,
up.
that's a good point.
We don't
did
know.
it just because they were closer.
Yeah.
They're closer to our project site, actually, the aero aggregate.
How did you achieve continuous insulation under the exterior door openings?
Under the exterior door openings, such a good question. And we cut that slide from our presentation, although it's still here. Can I unhide it? Let's see. Can you guys see that?
Yes. Oh, well.
Can you see slab door detail? No. I don't know that I can unhide it live. But the bottom, well, so it's two different approaches depending on whether it's the slab on grade foundation or ICF. But the long and the short of it is that it's finicky, and
we cut a notch into the slab. We put in a spacer, like a wood block, under the door and extending about 6 inches outboard of that both directions. When we poured the slab, we then took that out and put in Armatherm,
which is like super high compressive strength rigid. So we essentially like notched in to the slab high compressive strength rigid insulation.
And that's continuous to the insulation on the perimeter of the slab.
Yeah. And it's a similar concept for the ICF, though the concept is the same, but the execution is a little different for the ICF.